All right, good day, everyone. Today we're gonna look at the question 9 for mathematics paper 1. We're gonna discuss calculus. Anyway, thanks to those that much more appreciation to those that that support. But anyway, I should say first of all. Shout out to those that they subscribed. Shout out to those that they like the videos. Shout out to those that they do comment in the comment section. And you also can do so by clicking the like button, clicking the subscribe button, and also do comment in the comment section because it does help me a lot to reach more people. Anyway, good people, please do the right thing. Anyway, let's get into it. Today, I think we're gonna focus more on the calculus. That is question 9, the one that deals with the graphs. So we're gonna discuss the few questions. Question 9. Anyway, let's get into it. Question 9 here says, sketched below is the graph of f of x with the which is equals to x cubed plus ax squared plus bx plus c. The x-intercept of f are at 0:3 and m, where m lies on the negative x-axis. So k here, k into 3, here is k. K into 0 is to -3 is the y-intercept of f. And then m and n are the turning point. M and n are the turning points of f. Okay, here is the graph. This is the sketched graph. So here is the turning point and m and n, and this is the y-intercept, and that is the x-intercept. Also, this one is the x-intercept. Be mindful of that. So as we go through the questions, you will see why I said be mindful of this one. Anyway, the first question says here, 9.1, show that the equation of f is given by f of x is equals to x cubed minus x squared minus 5x minus 3. So let's get into it. This is question 9. Question 9. So 9.1, they said we should show that the equation look alike. F of x is equal to x cubed minus x squared minus 5x minus 3. We should show that. We are required to show anyway. Okay, now let's just interpret the graph a little bit. If you can see that we are given that here is the x-intercept, and here is the turning point, and also an x-intercept. So by the look of things, the turning point there occupies the turning point, or anyway, I should like give you the ways to find this type of question. We have a way to find the general equation, that is f of x is equals to a into x minus x1 into x minus x2 into x minus x3. Here you use this one whenever you have a 3 x-intercept. Whenever you have 3 x-intercepts, you can use this general uh, this general form to find the equation for the graph. But there is another way to find the general equation, that is f of x is equals to a into x minus x1 into x minus x2, but this one is squared here. This one you can use it whenever you have a x-intercept and then x-intercept with a turning point on it. So if that point is a turning point but also an x-intercept, you can use this one. Now, since we saw that this one we can apply it to find the general equation, because we have an x-intercept here and then x-intercept but with a turning point. So let's use this general form to find this general equation. So here we firstly say f of x is equals to a into x minus x1 into x minus x2, but we square that. We square it just because we have a turning point and also an x-intercept. So be mindful of that. You only use it because you have a turning point and also you have a x-intercept in that point and also a turning point on that point, and you have one more x-intercept. So we use that general form to find the general equation. So let's show that it's those. Okay, now let's plug in here everything, but be mindful of that. Here on the on the statement above, they said f of x is equals to x cubed. So it means that here a is equals to 1. So here a is equals to positive 1, because here here on the statement above, they gave us that f of x is equals to x cubed plus ax. But anyway, just because here it's ax squared plus bx plus c, it will confuse you. But anyway, let me say here, let me say maybe d. Let's change that to d. So now we changed that to d. So here now we can just say here, just because that one that's our d now, the coefficient of x here, x cubed, I mean, is equals to 1. So we can simply say that d here is equals to 1. So let's plug in everything that we have. So here f of x is equals to we can write here a 1, but there is no need to write 1 because we don't usually write 1 in mathematics. So it's x minus our x1 here. Take note here, our x1 is 0, our is 3 is to 0, so that is our x-intercept. So let's plug in that 3 here, and then x minus our x2 here. You can see that m here is the turning point, but also an x-intercept. So but we don't have the x2 here, so we just say x2, and then we raise everything to the power 2, And then remember, we are given that there is a k that is the y-intercept. So we're gonna take this one as as a as a as a point as a point on the graph. So by taking that as a point on the graph, but remember something: f of x is the notation for for the graphs. So f of x is also equals to y. So this notation is equals to y. You can represent f of x by y, but also you can represent y by f of x. So now we can just say here y is equals to x minus 3 into x minus x2 squared. Hope you all see that. Now here the point on the graph, that is k into 0 is to 0 into negative 3. We're gonna take that one, and then we say here is negative 3, because here is negative 3, 0 is our x, and then negative 3 is our y. So we replace y here with negative 3, and then we say x is 0 minus 3, and then 0 minus x2 squared. I hope you all see that. Here is our x, and then here is our negative 3. That is x and that is y. The point on the graph that we use to find this x2. So now let's make things to look like simple. I would say negative 3 on that side, and we say 0 minus negative 3, and we get negative 3, and then we say 0 minus x2, we get a negative x2 squared. Then we say we divide this on this side with the negative 3, because we want to find x2 here, of which this one multiplies the variable that we want to find. So we divide this side with negative 3, and then this side with the negative 3, and then we cancel this one out. You can see that here negative negative, this one, it gives you a positive 1 on that side. So here is negative x2 per squared. So if you can take note here, if it's negative x, but to the power 2, remember what does that 2 mean? It says here negative x times negative x, so which is equals to positive 1 on this side. So when we times negative times negative, it gives us positive, and then x times x, it gives us x squared. So x squared here is equals to positive 1, and then we introduce a square root just because we want to find x here but not x squared. So then we have two signs. Whenever we introduce a square root on this number, on this other side, we introduce a plus or minus. Okay, then we are left with what here? We are left with a positive or negative 1. So we're gonna decide now if this side is gonna be positive 1 or negative 1. But if you can take note here on this other side, since you can see that here we have a 0, so all these numbers should be less than 0. So when they are less than 0, it means that it's negative. So then therefore our x here is equals to negative 1. our x is equal to -1, and then let's try to find the general equation, just because we got our x2 now. We're gonna replace our x2 here. Here we're gonna just replace x2 here, and then we find, you can see that we're trying to find x2. Now let's just replace f2 and then find the general equation. So now let me make a space here. Okay. Here, let's take it from here now. F of x here is equals to, f of x is equals to, here is that one, that d of ours. Here it's 1 into x minus 3, and then into x minus here the x2 here, x2 here, the one that we got, it's -1, so be mindful of that. I will say -1 here, and then we square everything. So we get here now, we'll get x minus 3 into x plus 1, but we square everything there. And then we try to split this one. We say here now, let's say here x minus 3 into x plus 1 into x plus 1. Let's try to let's try to multiply the brackets out, and then we say x minus 3, and we say, let's start by multiplying this one out. We say x times x, we get now x squared, and then we say x times 1, we get x times x, I mean 1 times x, it means we get another x, and then we say 1 times 1, we get a +1. So, and then now these one are the like terms. I will say here x minus 3, and we get x squared plus, when we add them out, they give us +2x, and then with a +1. Now we say now x, we will try to break this one out, and we say x times x squared, and we get x cubed, and then we say x times a +2x, we get a positive 2x squared, and then we say x times 1, we get a +x, and then we say now we change things to -3 times x squared, get a -3x squared, and then we say a -3 times a +2x, we'll get a -6x, that is -6x, and then we say -3 times a +1, and we'll get a -3 here. So now let's try to add the like terms, and then we'll get our general equation. So it's x squared, x cubed here, and we say +2x squared and minus 3x squared, we'll get a negative x squared, because plus -3 plus +2, it's -1, and then I said there's no need for us to write a -1, -1 here to represent that it is 1. Anyway, we're trying to make our our life easier by saying by not writing 1 there. So it's x cubed minus x squared, and then positive x minus negative 6x. It's a negative 5x here, and then we get a negative 3. So let's see if it gives us the one that they said we should show them. So I think it gives us exactly the one that they said we should yeah. So it's x cubed, here is x cubed, and then it's negative x squared, here is negative x squared, here is negative x squared, and then negative 5x, negative 3, and then it's negative 3. So we are done here for 9.1, and then let's jump to 9.2. So here they said we should find let's calculate the coordinates for n. Let's calculate the coordinates for n. And they said here calculate the coordinates for n. So here is n. Our n here is a turning point. So to find the turning point, we have to derive for the first derivative, and then we should find our n, the turning point. So whenever they ask the turning point, be mindful of that. You have to derive to find the turning point. So we will derive according to our general equation. So now says here 9 point. Okay, 9.2 here. It's let's calculate the coordinates for n. Anyway, let's firstly write our equation. F of x is equals to x cubed minus x squared minus 5x minus 3. There is our equation, and now let's derive our equation to find this one. To find n here, we have to derive this equation. So here it's f prime of x is equals to m. That means it's a gradient. So here f prime of x is equals to we are deriving that equation. So it will be 1 times 3. It means that we multiply the power with the coefficient of that exponent that we are deriving with respect to, and then we minus 1 to that exponent. So we say 1 times 3x and then 3 minus 1. You see what we've done here, and then negative 1 times 2, that is the power, and then x to the power 2 minus 1. Those are the rules to derive the equation. So minus 5, that means here we have a 1 here. So we say 1 times 5x, then 1 minus 1. And then the derivative for the constant is just 0. Okay, then we say here 1 times 3, it is 3x, and then 3 minus 1, it gives us a positive 2. So it's 3x squared minus 1 times 2, it gives us a 2, negative 2, and then x, and then 2 minus 1, it gives us a 1. So then now we say here negative 1 times 5 is negative 5x, and then 1 and 1 minus 0, 1 minus 0, it gives us a, no, I mean here it's 1 minus 1, I'm sorry for that, and then 1 minus 1 is 0, and then it says here 3x squared minus 2x to the power 1 and minus 5, because anything raised to the power 0, it gives us a positive a 1. Okay, now we did derive the equation. So now let's replace f prime of x with a 0, because uh, m here, that means m is a gradient. So m here in this point is equals to 0. That is why we say here the graph is constant. So m here, the gradient is just equals to 0. Okay, now let's try to replace m with a 0. So this one is f prime of x, and then we say now here f prime of x should be equal to 0, because m now so let's replace f prime of x with a 0. So now we say 0 is equals to 3x squared and minus 5x minus 5, and then let's apply a quadratic equation to find the values of x here. So now we say x is equals to the quadratic equation is negative b plus or minus a root of b squared minus 4ac, and then all over 2a. So now let's plug in everything. Here is our a, it's our b, and then it's our c. So we'll take it with its sign. So now we'll say here negative b, negative into negative 5, and then plus or minus root into negative 5 again. We square, and then we say negative 4 into a here is positive 3, and then c is negative 5. So close that, and then we say divided by 2 into 3, and then let's punch in our calculator. Let's say here negative into negative 5 plus minus. Okay. Right now, the x values that I get are x is equals to negative 0.70, and then x is equals to 2.37. Okay, now if you can remember, if you can just remember to the previous question that we did get our m the the turning point that was equal to -1. If you can take note here, here is negative 0.7. When we now when we round off this number to the nearest whole number, you can see that it will be -1, because this one is greater than 0, and then we'll say to this number, we'll look at this number and say here, if it's greater than 1, we should add 1 to the previous number. So now we'll get our -1, and then now in this side, let's just say 2.37, just because this one is not greater than it's not greater than 5, so our x-intercept should be +2 this side when we round off to the nearest whole number. So n here n here it's on the positive x-axis, so now it should be a +2, and then m here should be -1, if you can take note of that. And then now let's try to find our y-axis. Now let's try to find our y-axis. Anyway, our y-axis now, take note of here, we have our x-axis, our x-intercept for the turning point. So now let's just say f of 2, because this one is our x turning point. So now we say f of 2 is equals to, let's go back to the general equation. The general equation was x cubed, anyway it is here, it was x cubed minus x squared minus 5x minus 3. So now f of 2 should be now 2 to the power cubed minus into 2x squared minus 5 into 2, and then minus 3. Let's punch our calculator now and see what we get. So now it is 2 cubed okay. Now we get a -9 for our y value for the turning point. So it's -9. So the n coordinates are 2 and -9. Here are our n coordinates. If you can see here, this is -3 and -3, and then if it's -9, it agrees, because this is -3 and -9. It means that it's lower than -3, and then this is 3 this side, and then it should be +2. So they make sense. So now let's jump to question 9.3. Let's jump to question 9.3, and then 9.3 has a 9.3. It has 9.3.1 here. These are the questions that people they get scared when they see them. For which values of x will f of x be less than 0? So here they ask us for which values of x will f of x be less than 0. So now let's just interpret our graph. So now if you can remember uh, let me just say for something to be less than 0, if you have a here, let's just say a, for it to be greater than 0, it should be positive. We should focus to the numbers that are greater than 0. It means that they should be positive. Those numbers should be positive. So if a here is greater than 0, look to the numbers that are above 0. And then when our a here is less than 0, we should look to the numbers that are less than 0. It means that those numbers should be negative. So if you agree with me now, let's look at the numbers that are anyway here f of x. We can just represent it with y. So let's look at the values of y, of which they are less than 0. For for the values of y of which they are less than 0, I mean, if you can look here, take a look here, just take a look here a little bit. Here is 0. Now our 0 here, uh, divides the Cartesian plane into positive and into negative numbers. So now if it divides our those values, what about these numbers that uh, are from here to this side? So these numbers, they are positive. If you can take a look here, we have a 1, 2, 3, 4, 5. Those numbers are positive. It means that our graph here must be positive. So we'll look at the values of y with respect to x. So we'll look at those numbers with respect to x. So if they did ask us about the numbers about f of x that is greater than 0, it means that here it's our a value of x here, our value of x, and here if you can take a look, this graph is positive this side. It means that our f of x is greater than 0. So when we look here, here our values of y, take a look here on this point. It means that 0 is to -3, and then this is our y value, this negative 3. It means that our values of y here, they are negative all the way down. They are negative. So now this is our graph. This is our graph. So they ask us about the values of x for which f of x is less than 0. It means that when it's less than 0, mind you, it's negative. It means that it's negative, it's below 0. So this is our graph. Let's look at the values of x for which this is negative. So now our graph here is negative, is negative, is negative, is negative. Our y values is negative. They are negative, they are negative. You can see that here they say it's -3, and here we did find our value of n. The coordinates of n as 2 and -9. So it means that here our graph is negative, is negative, but here our graph is 0, and then here when you turn from that turning point, you go down, you go down, you go down, you'll find it having values of y that are negative. So now let's interpret let's write our interpretation as from this value of x, you go down, you go down, you go down. Here, our value of y is negative. It continues to be negative up until to that point of m, to that point of m, that is the coordinate turning point, I mean. So to that turning point, you find our value of y being 0. So 0, you can't say 0 is negative or positive. So 0, they say 0 doesn't have a sign. So let's just say from here to here, our graph is negative, and then from here to here, our graph is negative. So let's say so now. Let's just write our interpretation as from here our value of x from the m intercept or x intercept, that is the point m. Our coordinates are here. This is our m, and now m here, it has a -1 coordinate with a 0. So here, and then we have that point, this point that is 3. 3 is to 0, and then we should say that our graph is negative. Our x value, let's say x here, where we look on the values of x for which this graph is negative. So let's take the value of x that is this graph is decreasing, is negative on this from -1 way down. So x should be negative, should be less than -1. That is our first value of x, that is represent x, f of x as negative, as less than 0. And then let's try to find our next x value. So this, if you can look here, take a look here, this graph is negative all the way to there. So now we should say now our x is between, it's in between this value that is -1 and +3. Here is -1 and here is +3, and then this graph is negative all the way down. Here it's negative because it's below 0. And then now we did that. We did 9.3.2, and then let's look at 9.3.2. Here now 9.3.2, it says here f be interesting, for which values of x will f of x be interesting. So if our graph is increasing, it means that our m value, our m or our gradient must be positive. So now let's interpret again, looking at this graph with respect to the values of x that it has. So now the value of x, let's firstly look at the graph. Here's the graph here, and when we do the rule method, it means that you put a rule on your graph like this. You look at it, you say now here I am, I'm looking at this graph. What is happening to the anyway, let me put it like this. by saying this is my 0 now, and then as I go from this point to this point, I'm increasing in values of my ruler. What is happening here? I'm increasing, I'm increasing, I'm increasing, I'm increasing, I'm increasing. I hope you all see that, because I'm starting from the zero, from the 0 point here, 0 centimeters, according to my ruler. As I go step above, I'm increasing in value, because I'm in 1 centimeter now, I'm in 2 centimeter, I'm in 3 centimeter, I'm in 4 centimeter, I'm in 5 centimeter now, I'm in 6 centimeter, then I'm in 7 centimeter, and then my graph turns. What is happening now? It's turning, because this one is a turning point, and then it means that uh, I can't go beyond this 6, but I'm turning, and then this value should uh, 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 differentiate which uh, which side of the graph that is increasing and which side of the graph should decrease. So let me put it like this again, and say this is my point, uh, 0 centimeter, and then let me go beyond, let me go and reach n there at the turning point. So I'm in 0 now, and I say 1, 2, 3, 4, 5, 6, 7, 8. What is happening now? If you can take a look here, I'm increasing, but I'm going down. If you can see, the values of this ruler are increasing, but below I'm pointing down. But if you can refer this to this, you can see that you are increasing, going towards 0, but you are increasing, going away from 0 now. Take note of that. You are increasing in the values of the ruler, but going below 0. So you are increasing here, going towards 0. So it means that my graph here is increasing, and then my graph here is decreasing, because it's going away from 0, and then it's going towards 0. So now if you can one more time, we put our ruler here, and we say here, this is our graph. We start from 0 here, that is the point, M, the turning point. So now we say M, one step forward, we reach 1 centimeter, 2 centimeter, 3 centimeter, 4, 5, 6, and then beyond 6. It's 7, 8, and 9. So as we go up there, you can see that we're approaching 0, and then we go past through 0. So it means that our graph here is increasing, and our graph here is decreasing, and our graph here is increasing. Please take note of that. You can use the ruler method. I'm giving you that ruler method to use it more wisely, and then you can get these free marks here. That is f of x interesting. So now it's 9.3.2. It says so our x value, it means that x should be less than negative 1 here. Let me say here f of x increasing. So here it's our value of x. It's our value of x starting from the turning point. Go there, go towards infinity, and then you can say that the this one we said it's increasing according to the ruler method, and then this one is decreasing and this one is increasing. So let's say n here, the x value for n, they ask us for which values of x, so we're gonna focus on the values of x when we write the notation for the values that are increasing. So x should be greater than positive 2 now. So hope you see that. Should be greater than positive 2. It means that for every value of x, as you go from x that is 2. So now we did look at the one that x values for the graph of f is increasing. So now let's look at the one for which values of x will f of x be concave up. Okay, now let me remove this one, and then let's say now 9.3, 9.33 here, 9.33 for which values of x will f of b be concave up. So when it comes to concave up, when it comes to concavity, by the way, we have to look at the graph. Okay, anyway, let me say for the concavity, it is where a graph changes from concaving up, or anyway, I mean at the point of inflection. The point of inflection is the one that determines the graph as concave up or concave down. So for us to get this question correctly, we have to find the point of inflection first. So to find the point of inflection, point of inflection, point of inflection. To find the point of inflection, to our general equation, that is f of x, which is equals to x cubed minus x squared and minus 5x minus 3. We have to find the second derivative, because the first derivative, it has to do with the gradient of the graph. So we have to find the second derivative. So our first derivative, it was 3x squared minus 2x and then minus 5. So that is our first derivative. So f prime prime, it means that it's our second derivative. So now we derive this first derivative as 3 times 2. It means we get a 6x, and then 2 minus 1, we get a 1. So now we say 1 times 2, it gives us a 2, and then we say 1 minus 1, it gives us a 0. So we're left with the 6x minus 3. So now for the concavity, so to find the concavity, if it says concave up, we should say to our first derivative, to our second derivative, I mean, it should be greater or equals to 0. So this concave up here, if it was saying concave down, we were going to say it's less or equals to, means that less or equals to, for this one it's concave, concave, concave up, and then this one f prime prime of x, for each that is less than 0, it means that is concave, concave down. Take note of that. So here is concave down, here is concave up, so our f prime prime of x should be greater than 0. Now we say f prime prime of x should be greater than 0 because our question here says concave up, and then we say now 6x minus 2 is greater or equals to 0, and then we transpose this 2 to the other side and we say 6x is greater or equals to positive 2, and then we say divide by 6, and then we get a x that is greater or equals to 1 over 3. So now our point of inflection, the one that the point of inflection here is 1 over 3, and then for that point it determines if this graph is concave down and this one is concave up. So that point is the point that that determines if the graph is concave up or is concave down. So now this one is our point where this graph is concave up. So at x is greater or equal to 1 over 3, here at x is greater than 1, is greater or equals to 1 over 3, it means that our graph is concave up. So we are done with concavity. And now we have to look at the 9.4. The question itself says here, determine the maximum vertical distance between the graph of f and f prime in the interval that is between negative, that is in the interval where x is between 0 and negative 1. So 9.4. 9.4 here. Okay, now anyway, for our f, so anyway, let me say first of all, to get the maximum vertical distance, there is a formula that we use, that is maximum vertical distance, which is equals to graph here on top minus the graph on bottom. That is our equation, anyway, the formula that we use. So MVD, maximum vertical distance, the graph that is on top and the graph that is on bottom. So I did highlight it now that our graph, since we did the question, I think the previous questions where they asked us to calculate the coordinates of n, I did clarify that we did got the coordinates of n, whereby it was positive 2 and then the one it was negative 1. So in calculus, the x values of the turning point of the original equation are the x-intercept of the first derivative. That is the graph. That is the quadratic graph. So the quadratic graph has an x-intercept that is the same as the x value of the turning point. So we got the x value of the turning point as positive 2 and then as negative 1. So it means that here we have our positive 2, our negative 1 as our x-intercept, and then the point of inflection, it is the turning point is the x value of the turning point of the quadratic graph. So now we have a graph that will look like this, and then we have this original graph that is for f of x. So this is our f prime and this is our f of x. So now here to get the maximum vertical distance, it means that since they said for which x is between 0 and -1, so we have to find a maximum vertical distance in this position here. So now I did highlight this. I chose it because it's in between 0 and -1. So now the vertical distance that we'll get here is the one that they will want. So now let's try to find, since here this one represents our graph that is on top, so our MVD will be equal to f of x minus f prime of x. This one represents the graph that is on the bottom. So now our is equals to, MVD is equals to, that is f of x minus f prime of x. Okay, so now f of x here, they said here is x squared minus x cubed minus x squared minus 5x minus 3. So in this place for f of x, we can say here is x cubed minus x squared minus 5x, here minus 3. And then we say minus into so now our f prime of x, it will be 3 x squared minus 2x minus 5. So that is our f prime of x, and then let's distribute that -1 into the bracket. So now it's x cubed minus x squared minus 5x minus 3 minus x 3 x squared minus positive, since it's negative times negative, so it's positive 2x, negative times negative again, it will be positive 5. And then now let's sum up the like terms. Let's add up the like terms, and we say x cubed minus x squared here is with 3x there. We have our negative 4x squared, because it's negative x squared minus negative, plus negative x squared. It gives us negative 4x, and then negative 5x with a positive 5, 2x, we get a negative 3 here, and then negative 3x, we get a negative 3x, and then negative 3 with a positive 5, and then we got a positive 2 here. So now we get our MVD, that is maximum vertical distance. By the way, since they said we should determine the maximum vertical distance between these two graphs, since they say the maximum vertical distance, mind you, the maximum or minimum vertical distance, it means that when they say a maximum, it means that you have to derive that equation that you got. You have to derive it. You have to derive it, and then let that derivative equals to 0. We will do much more of this in the application for calculus. So this one we will see it more often in the application of calculus. So now let's just say since we have a maximum vertical distance as that equation, so now let's derive that maximum vertical distance prime. We get a 3x squared with the 8x minus 3. That is our maximum vertical distance now. And then that maximum vertical distance should replace it with a 0. That derivative should be equals to 0. So now we say 0, and we say 3x squared minus 8x minus 3. And then now let's try to find the values of which find the x values here. So we can use a quadratic equation of which is a negative b plus or minus root of b squared minus 4ac, and then all over 2a. And then our negative b here, this is b, this is a, this is c. And then we say a negative into negative 8, a plus or minus, that is the negative into negative 8 plus or minus a root here. Now it's a root, and then a b squared, it will be a negative 8 again, squared minus 4 into a, it's a positive 3, and then c is negative 3, and then all over 2 into positive 3. And then now our first x value will be equal to x is equal to, and x is equal to. So now let's punch our calculator, and then we get now we get a first value that is 3, and then a next value that is 1 negative, negative 1 over 3. Since they said here in the interval that is x between 0 and negative 1, so we should go for this one, this x value here. We should go for this x value, and then let's go for it. Now let's try to find anyway, first of all, this x value here should be negative 1 over 3, negative 1 over 3. If you can take note of here, this x value doesn't change. It stays negative 1 over 3, and then the only thing that changes is the y value. So now let's try to find the y value so that we can find the maximum vertical distance that they want. So now let's go back to the since if you can take note of here, this one, this value of x of y, lies on this in this graph of that is f prime of x, and this one y value lies on this this graph there. So now we'll use a different equation to get the y values. So now let's start with the f of x, f of negative 1 over 3, that is the original one. Then we say 1 over 3 cubed, and then minus into negative 1 over 3 squared, and minus 5 into negative 1 over 3 and minus and then minus 3, and then we get a x value. So now we get a first value, and that is a negative 40 over 27 from the cubic function. So now that is our first value, and that is the y that is on the top, and then for f prime, that is negative 1 over 3, and 3 into negative 1 over 3, and then squared minus 2 into negative 1 over 3, and then a negative 5. Then there we get a value that is negative 4. Negative 4. And then we say our maximum vertical distance scanner is MVD is equals to negative 40 and minus or over 27 minus, I'm sorry for that, negative 40 over 27 minus into minus 4. Now we get a value that is 68 over 27. Sorry for that. All right, now we did find the maximum vertical distance that is between the interval of which x is between 0 and negative 1. So that is our final answer for that. Anyway, that's it for this video. Thanks for watching. Me and you, we're gonna meet in the next video, but until the next video, good people, please do take care. Don't forget to subscribe, to like the video, and do comment in the comments. That's it. Thanks for watching.